Here you are required to evaluate this integral. What you have here is a line integral. It's integral along a curve around a closed path of x cubed y dx. So this is the horizontal components of each vector in the vector field plus x y cubed dy. So this part is the vertical component of each vector in the vector field. Alright? A, you use direct line integration, and B, using Green's theorem. Now in an exam you might be asked to use direct line integration alone or Green's theorem alone or both. But anyway, let's look at how we deal with this using direct line integration. Now, you're required to perform this integration. I left out that part. You're being asked to perform this integration I just paused there to write that part of the question because I left it out. For x is greater than or equal to 0, less than or equal to 2, and y is greater than or equal to 0, less than or equal to x. Now, here we're going to start by using direct line integration. In order to use direct line integration, we want to see what the graph of this function will look like. So, if we have our x and y axis here, right, this is A we're doing right now. We have our x and y axis. The y axis look lean. Let me redo that. Alright. Now, x goes from 0 to 2. So we have a point here which we call 2. So along x is from 0 to 2. And then y is from 0 to x. That means at a certain point y is equal to x. So we're going to have the line y equals x. Alright? Now, of course, when x is equal to 2, y is equal to 2. So we go up to the line. This is 2. And when you have x is equal to 2, y is equal to 2, so this also reaches up to 2. Alright? Now, here, x is between 0 and 2 is this path. Alright? Now, with direct line integration, you want to go around a closed path in an anti-clockwise direction. So, we'll have to move this way, then go up, and then back down this way. Okay? You see that? So here, x is between 0 and 2. Y is between 0 and x. This line is y equal x, but this end point at x here tells you where to stop, right here. Alright? Now, this line has the equation x is equal to 2. And this line is, of course, the equation y is equal to 0. The x-axis has the equation y is equal to 0. This vertical line passing through x equal to is the line x equals 2. Then this line is the line y is equal to x. Alright? Now, sound is of me using my Zaparan mosquitoes, right, which have increased in number recently. But anyway, here now, you're going to integrate along each of the three paths. So let us go along the line along the line y equals 0 from 0 to 2. That means you will do the line integration right along here. You take that path, alright? So now, remember, when you're doing the line integration, what I want you to do is to use a parameter. Remember, you could write this entire function as x alone and dx, right? So this would be y equals x. So you would change this to x and this to x cubed, then the dy. If you find dy by dx, you get 1. So dy is dx, so you just change this to dx. So you'd get x cubed times x dx plus x times x cubed dx. Or you could change everything to y. Since y is equal to x, you say this would be y cubed times y. Dx would be equal to dy, because if you do dx by dy, you get 1. So when you multiply both by dy, you get dx equal dy. So you would have y cubed times y, which is y to the 4th, times dy plus y times y cubed, y to the 4th again, dy. But I want you to get accustomed to using a parameter, which is a new variable that you use alongside the two old variables you have, x and y. Alright? So let t be equal to x. Alright? Or I could write it and say let x be equal to t. Then y would be equal to, this is y, this is x equal t. It keeps changing. In this case, you look along this curve or along this line and see what y is. What do you think y is? Y equals 0, because you're along the x-axis, right? Now, you want dx in terms of t. If you do dx by dt, you're going to get 1. So what that means is that dx is equal to dt. So let's write this down. Dx equals dt. So you're going to look at dx and change it to dt later on. So the change in x is the same as change in t. Now what is dy? You need to know what dy is, right? Because we have it right here. Now notice dy would mean a change in y. But as you go along this horizontal line, y does not change. In order for y to change, it would have to increase by having some upward movement, or decrease by you having some downward movement. But it remains flat. So dy is equal to 0. So you have all of these variables here, and you substitute them into this function. Remember, this is a function of the vector field that we're talking about. So you write this now. You're going to integrate from, now this is in terms of t. So where does t start and where does t stop? Well, if x is t, x and t are the same thing. And the thing is, x goes from 0 to 2. So t goes from 0 to 2 as well. Alright? So it's from 0 to 2 of, let's look at this now, x cubed y dx. You have x cubed y dx plus, what was it again? xy cubed dy. xy cubed dy. Now, here, we said x was t. So, this changes to t cubed. Now, what was y? Y is 0. So, it's t cubed times 0 times dx. dx is actually now dt. Alright? And you want x now. Let's change out everything here as t dt. X is t. So you write t here. Times y cubed. Y is 0. So this is 0 cubed dy. dy is 0. So it's 0 cubed times 0. So what's the integral here? You're integrating 0 plus 0, which is 0, from 0 to 2 dt. Right? So the answer here would be 0, no matter how you take it. It's going to be 0. So this integral is 0. Alright. The next part now. Along x equal 2 from 0 to 2. It goes up to 2. X equal 2 from 0 to 2. Alright. Now going along this path. X is 2. Let's write that down. X is equal to 2. You can't say x is t because x is already fixed. So in this case, make y is equal to t. You see t changes, y changes, so let's y be equal to t. Next thing we want to know is what is dx. I want to know what is dy. Now what is dx? Notice that x is equal to 2. And as you move along this path, x doesn't change. So dx meaning the change in x. The difference in x is 0. So dx is 0. Alright? What about dy? Alright, you have y equals t here. So dy by dt is equal to 1. So if you multiply both sides by t, you get dy is equal to dt. See that? Alright, let's erase this. And we substitute our values. Now, we integral from. Alright. This is going to be integrated with respect to t. Now, y is t. Where does y move from where to where? Y moves from 0 to 2. So if y and t are the same thing, it means t moves from 0 to 2 as well. So you're integrating from 0 to 2 of, now the function is x cubed y dx plus xy cubed dy. X cubed y dx plus xy cubed dy. Now, here, what you have is that x is 2. So this is x cubed is 2 cubed times y. Y is t. So y is equal to t. dx, what is dx? dx is 0. Because x did not change. So it's 2t times 0 plus x is 2 So this is 2 times, and then we have y cubed. But then y is t. So what you're going to have is t cubed. Since y is t, y cubed is t cubed. And dy, we found out here that dy is dt. So we change dy to dt. So we have consistency throughout. We don't have two different letters, and we don't have d one letter and d another letter. Right? We have only one letter, one variable throughout. And we have dt. Oh, this, yeah, dx was 0. This part is 0. So what you have here is the integral from 0 to 2 of 2t cubed dt. Alright. Now, we're ready to integrate that. What we have here is 2t to the 4th over 4 from 0 to 2, which is equal to, this would be t to the 4 over 2 from 0 to 2, right? Equals, well, 2 to the 4 is what? 16. This would be 16 over 2 minus 0 to the 4 is 0 over 2. So it is 16 over 2, which is 8. So when you integrate along this path, you get 8. So that means if you move a particle from here to here through this vector field, which is a force, you're saying that your work done, which is forced by distance, is going to be 8. Alright? 8 units. Anyway, one last part of this region that we have to deal with now, right, is along y equal x. Now notice the direction, this way. So let us see what's going to happen here. Let's work on the right hand side here. We're going along y equals x from, is going to be from 2 to 0, not 0 to 2, not 2 to 0, because we have to follow the arrow. We're going around the region from 2 to 0. Alright? Now, let's see how this is going to go. Y equals x. We want to change x and y to t, and dx and dy to dt. So, let x be equal to t, the new variable. Alright? Now, since y is x, it means that x is t, y is also t. Alright? Now, if we want dx, to find out what dx is, just differentiate this and say dx by dt is going to be, or is going to be 1. So if you multiply both sides by dt, dt and dt cancel here, dx is 1 dt, so dx is equal to dt. Alright? And then we want to know what dy is. Now if you differentiate this with respect to t and say dy by dt, you're going to get 1. So when you multiply by dt, multiply both sides by dt, dt cancel dt here, and you have dy equal 1 dt. So dy is equal to dt. Okay. So let's look at what happens after this now. We have the function of the vector field. It's the integral from of x cubed y dx plus xy cubed dy. The integral of x cubed y dx plus xy cubed dy. Now, you're going to have x is t. So this x is really t. So x cubed becomes t cubed, right? You want everything in terms of t and dt. Y is t as well. So this y, erase it and replace it with t. Alright. Plus x. This x is t. You put t there. And this y is also t. So y cubed becomes t cubed. Now what about the dy? Well, we see here that dy is dt. So we write that as dt. Okay. So what we have here now, let me just draw a line to separate the work. This, oh, by the way, the boundaries. When you look at this, y goes from 2 down to 0. X goes from 2 to 0 as well. Now look at this. X is t and y is t. So both of them go from 2 to 0. You start at 2, you end at 0. So 0 is the upper boundary and 2 is the lower boundary. Alright? Now let's put this all together. This is the integral from 2 to 0 of t by t. T cubed by t is t to the 4th. Oh my, I still have dx here. It's dt. This should be. dx is dt. Alright. 2 to the 4 dt plus t times t cubed is t to the 4 dt. So what we have is the integral from 2 to 0 of 2 to the 4 plus 2 to the 4 is 2. I mean t to the 4 plus t to the 4. T to the 4 dt plus t to the 4 dt will be 2 t to the 4 dt. So that is what we're going to integrate, alright? So here, we say 2 t to the power of 5 over 5. And we're going from 2 to 0. See that? Now that will be equal to 0 is the upper boundary. So it's 2 times 0 to the 5 over 5 minus the lower boundary 2 times 2 to the 5 over 5. Right? Now, what do you get when you do that? This part is going to be 0. Right? So it's 0 minus 2 to the 5 is what? 2 2s 4, 4 2s 8, 8 2s 16, 16 2s 32. So it's 2 times 32 over 5, which is negative. 2 by 32 is 64 over 5. Okay, good. Now, the integral is equal to, now, if you want to give these names and say this is along curve 1, this is along curve 2, this is along curve 3, you add up all the path together. C1 plus C2 plus C3, where C1, I call it C1, is going from 0 to 2 along y equals 0. C2 will be going from 0 to 2 along x equal 2. and C3 would be going from 2 to 0 along y equals x. Alright? Now, when we went along the first one, what we got was 0. Then along the second path it was 8. So it is 0 plus 8 plus. Then along the third path, as you see here, it's negative 64 over 5. So what we have, alright, this is 8 over 1 minus 64 over 5. How do we deal with this now? Let's use common denominators. Say 8 over 1, multiply top by 5 and bottom by 5. So we have something over 5 minus 64 over 5 equals 8540 over 5 minus 64 over 5. Alright. What is 40 minus 64? It would be the negative of 64 minus 40. This is what is it? 4 minus 0 is 4. 6 minus 4 is 2. Alright, so what you have here is negative 24 over 5. Alright? That's what you have there. Negative 24 over 5. Let's write the answer here. Negative 24 over 5. Okay. Now, having done that, I want you to pause the video and then work out part B. Do it using Green's theorem. We're going to look at it together in the next video. But watch that video only when you are finished and you're supposed to get the same answer, negative 24 over 5.